At the roundabout, take the second exit. Keep right. You have reached your destination.
In this video, we'll try and find our path to some solid 2D pathfinding in Unity. Now, the Unity navigation system doesn't actually support 2D, so instead we'll be using the A* pathfinding project to quickly and easily set up an enemy that will find the shortest path available to our player. The A* pathfinding project is of course completely free, and the best part is that we'll be able to do it all without writing any code. After that, we'll have a look at how you can achieve the same thing by writing your own custom script. And the cool thing about this is that you'll be able to extend and modify it in any way that you'd like to fit your AI needs. But first, this video is sponsored by Skillshare. Skillshare is an online learning community with more than 28,000 quality classes on game development, tech, and more. If you've always dreamt of making your own mobile game, I can definitely recommend this basic Unity course on making mobile games for Android and iOS. At the end of the course, you'll be comfortable with mobile setup and input alongside a bunch of other topics like score systems, procedural level generation, and Unity's ad system. Join more than 7 million other creators by simply clicking the link in the description, and the first 500 people will receive their first 2 months for free. Alright, let's make some enemies. Please don't hold grudges. So as you can see, I've created this simple example level with some environment pieces and a main character that we can move around. The scene also has this bird here, which is basically just a sprite renderer with an idle animation. Currently it does nothing and will not chase our player at all. So let's go ahead and change that with some AI pathfinding. First of all, we need to visit the website for the A* pathfinding project. I'll of course have a link to this in the description. Here we'll go to download, we'll navigate to the free version, and we'll hit the download button. This should download a small zip file that we can then open up, and in here should be a folder containing a Unity package. Let's go ahead and double click that, and it should load right into Unity. Here we can see all the stuff included. Most of these are scripts that we are going to be using. Let's just go ahead and import everything, and once that's done, we are ready to set up pathfinding. To do this, let's go to the hierarchy, let's create an empty object, and let's rename this to a star. You can call it anything you want. I'm just going to place it at the top here, and I'm going to reset the transform. This object is going to be the central part of our pathfinding system, and it's going to define in what areas our AI can navigate. So let's go ahead and add a new component, and let's search for Pathfinder. Let's hit enter, and this is going to create the A* path script. Here we can go under graphs, and you can see that we can now create a new graph. We're going to create a simple grid graph, which, as the name suggests, is just going to lay out a grid on top of our level and then check for each grid cell whether or not there's something blocking it. Of course, we're working in 2D, so I'm going to go ahead and check the 2D box right here. And now if we go into the scene view, we should see a very tiny grid graph. Let's go ahead and make this a lot bigger. So I'm going to switch into my scale tool. And I'm just going to simply click and drag to increase the size of this. Let's just have it fit pretty much our entire level here. We also want to go down here and check use 2D physics. And we can leave the collider type at circle, but I want to increase the diameter here to something like 1.3. And this basically just means that it will try and overlay a circle on top of each of these nodes to see if it collides with anything. And that circle is going to have a diameter of 1.3. We also want to define a layer for all the objects that we don't want our player to be able to pass through. We can do this with the obstacle layer mask. As you can see, by default, it's set to nothing. Let's go ahead and go to our environment. I'm just going to select my middle tile map here. This could also just be a bunch of objects. It doesn't have to be a tile map. And as you can see, I've currently set this to the layer obstacle. Remember, you can always go in and add a new layer, test layer, and then go back to your object and assign it to that layer. I'm just going to leave this one at obstacle. Then inside of our A* object, we can set the obstacle layer mask to include the obstacle layer. And now if we go ahead and hit the scan button, you can see that A* is going to generate a navigation grid for us. Of course, all the areas that are blue are places that our enemy can navigate, and places that have red squares are marked as obstacles, and our enemy won't be able to move there. Now with this set up, I'm just going to hide the graph here so that it isn't overlaid when we're working with other objects. And we are now ready to set up our bird. To do this, let's go ahead and create an empty object. Let's call this object enemy, and let's parent our bird to that object. We can then reset the transform on our bird, and you should now have two objects stacked like this. The reason why I'm doing this is that I want to separate our graphics, which is the bird here. Let's go ahead and rename it to bird graphics, and the logic of our enemy into two different objects. This is super cool because it allows us to offset our graphics in any way that we'd like and easily change them out without having to modify our enemy object. Now, to quickly get our enemy moving around the scene, there's a default script that we can go ahead and use. It's called AI Path. Let's select that. And as you can see, it's going to automatically add a seeker script, which is something that we'll need for all AI objects, as well as the AI path script itself. The seeker script is responsible for generating a path to the target, and the AI path will control the seeker script and start moving our object in that direction. And we can leave most of the settings here as is. I'm just going to go ahead and change the orientation from Z-axis for 3D games to Y-axis for 2D games. And right away you can see that this circle appears around our enemy. We can of course adjust the radius of this if we want our enemy to be bigger when moving around. We can also adjust the max speed. I'm just going to set that to 3. And finally we can adjust how close our enemy should be to a waypoint on our path before it starts to focus on the next one. I'm just going to set this to something like 1.2. You can see the circle here. That should work for now. Of course, I could go ahead and hit play here, but you'll see that the only thing that really happens is that our bird flies straight to the ground. The reason for this is that it's currently set to use gravity. So let's just go ahead and disable that. It's also not flying towards our player because we haven't marked our player as a target. To do this, we want to add a destination setter component. This takes in a target. Let's just drag in the player here, and that's pretty much all we need to do. If we just hit play now, you can see that immediately our bird starts moving towards our player, and it's even doing so based on a path. You can see that it's flying around objects in order to get to him. In fact, we can turn on gizmos in the game view, and with the drop down button here, we can find the seeker script and enable gizmos for that object in particular. What this is going to do is it's going to draw the path that our object is taking in order to get to our player. Really, really cool. You can also see that our object is currently rotating in a really weird way. And we don't want this bird to rotate at all. So I'm simply going to go ahead and disable rotation on our object. And that should fix it straight away. You can also add colliders to your AI to make sure it won't fly through stuff in its path. To do that, let's hit add component and let's add a circle collider 2D, and that already looks pretty good. If we now hit play, we can see these changes working. You can also see that everything looks fine if we stand to the left of our bird, but as soon as we go to the right, we pretty much want this sprite to flip to face in this direction, similar to what we're doing with the player movement. Now we could go ahead and create a script from scratch to control our AI. And we'll have a look at doing that in a second. But if you just want to add this tiny thing to change around your graphics, we can add a very small script on top of what we have going on here. To do that, let's select our bird graphics. Let's hit add component. And let's just call this one enemy graphics. Let's create a new script. Let's hit create and add. Let's double click to open it up in Visual Studio. Now, whenever we're programming something with a star, we want to include a specific namespace. So we want to be using, and the name of this namespace is PATHFINDING. This will allow us to, inside of our script here, let's delete our start function and create a public variable of type AI path. Remember, this is the name of the script that we added to our enemy in order to control it. Let's just call it AI path with non-capital letters. Then inside of our update method, we can check if AI path dot desired velocity, and the desired velocity is the velocity that our enemy would like to travel with based on the current path. In other words, we can take the x value of this, so the horizontal movement of our enemy, and check that if this is greater to some small value like 0.01, well then we are moving to the right. And then we can do transform.localScale equals a new vector 3, and this is going to be -1 on the x, 1 on the y, and 1 on the z. And if this is not the case, we want to check if AI path dot desired velocity dot x is equal to less than -0.01, in which case we are moving to the left, and so we want to flip our bird in the opposite direction. So we can just copy this here, and this is going to be positive and not negative on the x. So we're just flipping based on our x speed. If it's positive, we're traveling to the right, and we'll set the scale to this. If it's negative, we're traveling to the left, and we'll set the scale to the opposite on the x. So if we save this and go into Unity, we can select our bird graphics. This takes in an AI path. We'll drag that in from the enemy. And now let's hit play. And as you can see, as soon as our bird changes direction, it's also going to flip the sprite. Really, really cool. So that is how you can super easily set up pathfinding using a star. However, the A-star pathfinding project is crazy powerful, and it of course allows us to write our own custom script to control our AI. So let's have a look at how we can do that. I'm just going to create a backup of our enemy here, so I'm going to duplicate it, and I'm going to disable the old version. Now for our new enemy, we can go ahead and get rid of the AI path script, the AI destination setter, and under our graphics, we can remove the enemy graphics script. Instead, we're going to handle all of these things that we just removed inside of one master script that we'll create now called enemy AI. This is going to be a new C# script. And before we open this up to edit it, we want to add one more component. So we have a seeker, a circle collider, and our enemy AI. We would also like to create a rigid body 2D. Now you can pretty much use anything to drive the movement of your enemy. It doesn't have to be a rigid body. You could also just use transform.translate or some kind of character controller. But in my case, I would like to use rigid body because then we can easily apply other forces to our enemy and it's instantly going to work with the rest of the physics system, which is just really nice. For now, I'm going to leave pretty much all settings as is. I'm just going to go ahead and freeze the rotation on the Z and set the gravity scale to 0. So if we play it now, we can see that our bird is just gently floating in the air. So to change this, let's open up our enemy AI script. Now this script does have some length to it, so I'm going to go forward fairly quickly. If there's something you don't understand, that's totally fine. If this is your first time working with AI, you might be a tiny bit confused, but let's try and take it one step at a time. So the first thing that we'll need is some variables. Of course, we'll need a reference to our target. So let's create a public transform that will take in our target. We'll also want some control over our speed. So we'll create a public float, speed, and let's just default this to something like 200. Next, we'll need a public float, which is going to store our next waypoint distance. This is the same thing that we adjusted earlier under our previous enemy. They just called it pick next waypoint distance. And again, it's just how close our enemy needs to be to a waypoint before it moves on to the next one. So next waypoint distance, let's just default that to 3. Finally, we'll need a few private variables, and for these we need to include the pathfinding namespace, just like we did before. So the first of these variables is going to contain our path. This is the current path that we are following. We are also going to have an int that is going to store the current waypoint along that path that we're targeting. And finally, we want to know whether or not we have reached the end of our path. So let's create a bool called reached end of path, and let's default it to false. Finally, we need to be able to reference our seeker script as well as our rigid body 2D. So let's go ahead and create a seeker variable called seeker and a rigid body 2D called RB. Now inside of our start method, we can go ahead and find our seeker component. So let's go seeker equals get component of type seeker. Let's do the same thing for our rigid body. So let's set RB equal to get component of type rigid body 2D. This is just going to find the two components on our object. And then we're ready to generate a path. To do this, we access our seeker. This is responsible for creating paths. And we want to access the function called start path. Here we first need to define a start point. So that's the current position of our enemy, which is rb.position. Next up, we give it the end of our path. So that's our target's position. So target.position. And finally, we give it a function. This is the function that we would like it to call whenever it's done calculating the path. We do it this way because depending on the complexity of your scene, generating a path might take a little while. And we don't want our game to be hung up with generating a path. It should just do this in the background and notify us once it's done. So this is just the function that it should call when it is. And let's just call it onPathComplete. We can then create this function. So let's create a void on path complete. This is going to take in a path called p, and this is the generated path. We then check if we got any errors. In other words, we want to make sure that we didn't get any errors. So if we didn't get p.error, well, then we want to set our current path equal to p, the newly generated path. And we also want to reset our progress along our path. So we'll set current waypoint equal to 0 to start at the beginning of our new path. Awesome, so now we should have generated a path and be ready to start following it. In fact, we can check if this works by just saving this, going into Unity, and we now have our target variable where we need to drag in our player. And if we then hit play and go to gizmos to make sure our seeker is included, we can see the generated path. We can also see that it's not updating to follow our player. It's just generated at the very beginning. And our bird is also not doing anything to follow it at the moment. So let's go ahead and change these two things. First of all, let's have our bird move. To do this, we go into our update method. And the first thing that we want to make sure is that we have a path. So if path is equal to null, well, then we'll just go ahead and return out of the function. We also want to make sure that there are more waypoints in the path and that we haven't reached the end, because if we have, we want to stop moving. So to do this, we want to check if our current waypoint is greater than or equal to path.vectorpath.count, so the total amount of waypoints along our path, well, then we've reached the end of the path. So let's go reached end of path equals true, and let's just return. If our current waypoint is not greater than or equal to the total amount of waypoints, well, then we can go ahead and set reached end of path to false. And that's it. So now we can go ahead and move our bird. To do this, we want to first of all get the direction to the next waypoint along our path. To do that, we create a vector2, let's call it direction, and we want this to be equal to our path.vectorpath. And here we want to find our current waypoint along that path, so we'll pass in our current waypoint. So this gives us the position of our current waypoint, and we'll subtract from that our current position. This should give us a vector that points from our position to the next waypoint. We also want to go ahead and mark this as a vector2, because rb.position is a vector2, and so we need to cast this into 1 as well. And finally, we can wrap all of this in parentheses and add a dot normalized in order to make sure that the length of this vector will be 1. If you haven't worked a lot with vectors before, simply think of this like we're pointing an arrow from our current position to the place where we want to be, which is our next waypoint, and then making sure the length of that arrow is always 1. And we can now get a force that we want to apply to our enemy to make it move in that direction. So let's create a vector2, let's call it force, and set it equal to our direction multiplied with our speed, multiplied with time.delta time. We multiply with time.delta time to make sure it's not going to vary depending on the frame rate. I also want to change this from an update to a fixed update. Fixed update is just like update, however, it's only called a fixed number of times per second, which means that it's ideal whenever you want to work with physics. Finally, we want to figure out the distance to our next waypoint. To do this, we will go float distance and set it equal to vector2.distance between our current position, so rb.position, and the next waypoint, so path.vectorpath, and we'll input the current waypoint. We can then check if that distance is less than our next waypoint distance. Well, then we've reached the current waypoint and we're ready to move on to the next one. So we'll simply increase current waypoint by 1. And that should work. Oh, and then I just forgot the most important part, which is actually adding our force to our enemy. So let's just go rb.addForce, and we'll just import our force vector. That's all we need to do, but it's quite an important step. Let's save that, go into Unity and hit play. And as you can see, our bird now moves, but it does so without stopping. The reason is we are applying a lot of force to our bird, and it doesn't have anything to stop it again. Luckily, we can easily add some air resistance, also called linear drag, to slow it down. Let's just set this to something like 1.5, and let's also increase the speed to something like 400. If we hit play now, we can see that our bird indeed comes to a halt. Much better. Now we just need the path to update to follow around our player. And doing this is actually fairly easy. All we need to do is go to the top where we are currently generating our path at the start. And instead of just doing this once, we need to keep doing it at an interval. This is super easy to set up using a function called invoke repeating. This allows us to specify a method. In our case, we can create something like update path, then a amount of time we want to wait until we call that method. We just want to call it instantly, so let's set that to 0. And then we can give it a repeat rate. And this is the awesome part. So we can have it update the path every second, every other second, or every half second, which I'm going to do. Then all we need to do is take this code that updates our path and put it inside of our own function. So we'll create a void update path and we'll paste that code right in. We also just want to make sure that we aren't currently updating our path and then begin updating once more. So to do that, we'll just write if seeker.isDone, which means that it isn't currently calculating a path. Well, then we can go ahead and start a new one. And with that, we can save, go back into Unity and hit play. And as you can see, our bird is now continuously going to update its path towards our player. Really, really cool. Now we just need to make our bird actually flip to point in the direction it's traveling, just like we did before with the bird graphics. However, now I would like to do this within the same script. So let's just go to the top here and create a public transform, which is going to reference our enemy graphics. And then at the bottom here, we just need to add some code very similar to what we did inside of our enemy graphics script. In fact, we can go ahead and copy this. And then instead of using aipath.decideVelocity.x, we can simply use rb.velocity.x. And the same thing here, rb.velocity. So just the current velocity of our rigid body. And we don't want to adjust transform.localScale. Instead, we want to adjust enemy graphics.localScale. So let's save that, go into Unity, let's drag in our bird graphics and hit play. And as you can see, our bird is now going to always point in the direction that it's traveling. Really cool. In fact, maybe an even better idea is using the force instead of our RB velocity. This way it will actually rotate to point in the direction that it wants to travel and not just the result of our velocity. So if we save that, that should actually look even better. Yep. I definitely like that quite a bit. Also, just if you want to get rid of all these annoying debug logs, they might be kind of slowing down your system. You can always go to A*, and under settings, you can go to debug and set path logging to none. That should help get rid of them. Awesome. That's pretty much it for this video. If you enjoyed it, make sure to subscribe and ring that notification bell so you don't miss the next one. Also, don't forget to check out Skillshare. Simply click the link in the description to get started, and the first 500 people will receive their first 2 months for free. On that, thanks for watching, and I hope you will all find your path to the next video. Also, special thank... Hey, do you want to do it? Yeah, you should do it.
Alright. Thanks to all of the Patreon supporters who donated in April, and a special thanks to Infinity PBR, Cyborg Mommy, Dennis Sullivan, Chris, Shane Cleveland, Faisal Marify, Lincoln Chung, Leo Lisette, Runen, Daniel Dusanik, Konstantinas Karentas, Naoki Iwasaki, Gregory Pierce, Rob Fern, Dr. Poon,